check. Y'all did it already. I was telling you.
Oh, I thought maybe you can present this also.
No lah. Not part of the. Not part of the.
Yes. Do you still have other capstone after this?
We just came from one.
Wow.
Yes,
Yeah,
I still have another one.
At 3 o'clock. Yeah. Infants.
Yes, infants group.
Yeah. Okay, without further ado, we can just start. Okay, so good afternoon to our client, Mr. Jin, our supervisor, Mr. Ben, and our second marker, Mr. Wesley. Today we're going to present our capstone project using the Temi on energy. So just a brief introduction to our teammates. It's me, Jin Yan, and Hakimi. So all of us are all full stack developers, meaning that we all in charge of coding the front end and the end of the application. And for me, but we also have our individual roles. Let's say for me, I'm a team lead, and testers means that I'm the one that handle all the administrative tasks, like communicating with our stakeholders, with our team's needs. And I'm also a tester that creates a program to test our app. For Jin Yang, he's also a full stack developer as well as tester and troubleshooter. He's the guy that we look for when we have problems, and he will help us to solve them. For Hakimi, he's also a full stack developer as well as a software architect. So he's the one that during meeting, he's the one that draws all the diagram while we have meeting with our client. And then the diagram will help us to understand the business requirements and what our team is going to do. So this is just a brief, like the project timeline from the start of day 1 to until now. So on week 1, we actually had a short session with our client, Mr. Jin, that he actually briefed us about what is expected in this project, like the basic features and advanced features. And from week 1 to week 8, we actually don't have robot with us. That's why we work on something that without robot, let's say the server, and doing some research on the Temi SDK package. Then on week 8, we finally received the robot, and then we can finally work on the application and all the deliverables. So, and then from week 8 to week 12, we actually have the time to do our basic feature, and finally come up with something to showcase in open house. And that's when we conduct our mini VIVA for the basic feature, and a little bit of our advanced feature at that time. So from that time until now, it's around like 4 weeks. We actually finish out all the features, and we are ready to demo later after this presentation. So this is our project objective. Firstly, we are supposed to develop an Android application that is downloaded on Temi robot that's able to help the patron to find the book by navigating him to the shelf. And in case the book is located on another level, the request will be sent over to a server, and the server will redirect the request to the other Temi. And this will be going through a seamless communication so that it flows well, because yeah. And these are our final deliverables that we'll showcase today. It's our basic feature and our advanced feature. Basic feature is basically how the Temi navigate the patron on the same level. On level there's many bookshelves, it's able to go to all the bookshelves. And for advanced feature, it's basically different levels. How does two Temis communicate with each other and pass the task over through a server? This is now we're explaining a more in-depth details of how this entire thing works through our solution diagram.
Okay, so this is our solution diagram. So basically, these two boxes represent Temi 1 and Temi 2, which will be on different levels in the library. This is our Python Flask server, which facilitates communication between both the Temis. And this is the library server, which contains the library website. So to use this diagram to explain the basic feature, firstly, a user will use the library website to search for a book on the Temi itself. Then on the website, there will be a URL that they can click in order to be redirected to the app on Temi, which we made. Upon redirection, we also pass in some data about the book, such as book ID, book name, shelf number, and level to our app. And using this data, our app can tell whether the book is on the same level as the Temi, or if the book is on a different level. If the book is on the same level, a function we wrote in the app will activate, and the Temi 1's guide activity will activate and lead the user straight to the shelf that contains the book you want to find. So yeah, that's it for our solution diagram. The next diagram we have is our state diagram, which basically shows the current condition of Temi throughout the runtime of our app. I know it's hard to see here, but this is called idle, which is basically the initial state of Temi when the app is launched. This state basically means when Temi is waiting for users to come and use it to find books and locate books. When Temi is in idle state, it can transition to guiding state where the user uses Temi and searches for a book. This condition means when if the book level is the same as the Temi level, the guide to book function will activate and cause the Temi to transition from idle to guiding state. Upon entering guiding state, Temi will go to the shelf that the user is trying to find. This is basically similar to for the waiting state as well, except the guard condition for the Temi to transition from idle state to waiting state is different. So basically, in order for Temi to go from idle state to waiting state, Temi has to receive a signal from the server saying that a user has sent a photo to the server and is awaiting facial verification. Then upon receiving this signal, Temi will transition to the waiting state, and when Temi enters the waiting state, the Temi will move towards the waiting area and wait for the user to perform facial verification. So yeah, that's our state diagram.
So to help you better understand the state diagram earlier, I'll be going over the advanced feature. So this is the scenario where users are looking for a book on another level through the. So we have two Temi robots, so client 1, client 2. So we'll just assume this as level 2 and this as level 3. So arriving at level 2, he wants to find a book on another level. He clicks on the link and he is requested to take a picture of himself. So next slide. So the data of this, the data that will be sent to the server will be the book information alongside the picture of their face. So then the server will then send over to the second client, which is the second Temi, information of the book. So once Temi, this second Temi receives that information, next slide, it will then move to the waiting area, which is near the staircase. So it will be waiting for the user near the staircase. So while this is happening, while this robot is moving to the waiting area, the user will then be making his way up the stairs to the waiting area. So then once he reaches there, he is requested to take a second picture. So once that second picture is taken, that picture will then be sent back to the Flask server, where the Flask server will then make use of a Python library called Deepface, which takes in 2 pictures and will send in a an output. So there are 3 different outputs being there are 3 possible outcomes to the output lah. So next slide. So the first outcome is that it detects that the 2 pictures contain the same face. So in that case, it will send back to the Temi saying, giving Temi the green light to say, okay, go ahead, you can bring the user to the book. The other 2 outcomes would be that the deepface does not recognize any faces in the image, or deepface does not deem that the 2 people in those images are the same person. So in those cases, we've set it such that Temi will just simply ask you to take a picture again. Otherwise, we've also set a secondary button that allows you to just skip this entire process. So next slide. So these are the special features that we've put in. So again, the face recognition that I mentioned earlier using deepface. So this is only in the scenario where the book is on another level. Otherwise, it's not utilized. Then with safe and ethical data collection, with the safe and ethical part, we're talking about how once you take a picture, that picture will be stored in the local storage of the Temi, right? So once we're completely done with this image, we delete it from the local memory. Then with the data collection part, we are talking about data that we collect in regards to what users click. So this is to set up for like future usage of this data. So the stuff we are collecting consists of the books that are being clicked, where they are clicked at, like what level, blah, 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 and also the date time. So next slide. So this is for the whole deleting of like the temporary files. So any images taken will then be deleted. And this is like it's hard to see, but it's a REST-DB where we collect everything. So every single time someone clicks, it's logged over here with a date time. So the reason we've done this is so that we can set up for further usage for analysis and whatnot, because it's something that we received like as not criticism but a suggestion during open house, where they were saying how we can collect this data. Then it's like with this we can tell like what genres are being looked for, like what kind of books are being looked for at this specific time, blah blah. Then it's like this kind of information can be used as like we can think of like moving the books of this certain genre to the first level because it's more accessible. So this is something that we set up for further like future stuff. Next slide. So this is something I've created for future developers when we want to move over from our our placeholder website to the library website. So this is a JavaScript function that takes in 4 values, which is the book name, bookshelf, book level, and book call number, and then generates a link that is specific to our Temi bot. So this link, when used on a Temi robot that has our app installed, when you click on it, it will basically function the way we want it to. So this way, future developers, once they want to transition, like bring this over to the library website, simply have to use like this code.
Okay, so now we're talking about some technologies that we use to develop our product. So firstly is Flask, which is a Flask server that we made to facilitate communication between Temis. We also made a function in our Flask server to handle the facial verification process. Next is Android, specifically Java, which we use to develop an app for our Temis. Then Nano HTTP, which is an Android package that allows users to set up a HTTP server on an Android app. So whenever our app is running, a HTTP server will be also running concurrently. Moving on is our Temi SDK, which basically allows us to write code to develop features that allow us to get Temi to navigate around the library floor. Then DeepFace is a Python library that allows us to compare 2 photos to see if the 2 photos contain a face that belongs to the same person. And lastly, our ResDB, which is a database service that allows us to store the book details for further use.
So during our development, here are our limitations. So what we have done better is that because we only received Temi halfway through our project, so if we are given more time with the robot, we'll be able to code a more function in it. And next is it's more about the physical setting while we are developing the project, because we can only work in the library instead of working at home, virtually. So this is one of, because we don't have that much time developing this project, especially in the library. And some of the team actually live very far away. They have to travel all the way to library just to spend the 2 hours with us to develop the project. Lastly is we are also unable to test our advanced feature because it requires 2 Temis. So that's why we come up with alternative is to install the app on our Android phone. And then we use this Android phone to simulate the second Temi, so that we have 2 Temis to try to communicate with each other to test our advanced feature. Now here are some problems that we face during our development, and we'll let our troubleshooter to help you understand here are those problems.
Okay, so some of the problems faced was that firstly, the Temi SDK is not compatible with Android emulator, meaning that if you try to run our app on Android Studio on an emulator, it will just crash, meaning that any virtual testing of the app was not possible. Next, we tried to do 2-way communication using a Golang server. However, this did not work for us, meaning that Temi1 could send over data to Temi2 through the server. However, after this first sending of data, if we wanted Temi2 to send data back, we don't know why, but we couldn't actually get Temi2 to send data back to Temi1. This issue was actually troubleshooted for quite a while, but we still couldn't figure it out, so we decided to switch to Flask instead. Next, when we received Temi, it was outdated, meaning that a lot of the essential tools that we needed to develop our project was not available at the time. So things like the map editor for us to put boundaries around the library to make sure Temi doesn't go to anywhere it's not supposed to go, as well as a working internet browser was not available when we first received Temi. However, after Temi was updated, the default browser that it came with also still did not support Android deep linking, which we needed to redirect users from the library website to our app. So we were forced to make our own custom browser that supported Android deep linking, so we could redirect users to our app as well as send data over through a URL. Lastly, Temi, when we were working on the face verification feature for Temi, we had to take photos of our faces. But when we realized that when we took our first picture, the Temi would crash due to memory capacity issues. So to fix this issue, we had to compromise and reduce the image quality, as well as delete the image once we are done with our facial verification process. So these are some of the problems we faced during the course of the project.
So I will go over what we can improve given the resources and time. So starting off with the facial verification with a better model. So currently we're using deepface, so it's free and it's for anyone to use. But moving forward, we want a model that's more accurate and more efficient. Accurate meaning it's able to tell with a higher success rate of telling apart like the same person, different person, wearing masks, wearing glasses, all these different things. With more efficient, we're talking about a faster computation time. So currently with deepface, we're taking about like 4 seconds, 5 seconds. Like it's a lot longer than we wanted it to be. But moving forward, what we can do is either to get a custom model, so like maybe a convolutional neural network that we create ourselves through Keras, or we can use like a paid service such as Luxen Face SDK. Next would be UI UX. So with the design and like the user experience, we didn't really focus too much on it. So it's there, but we can improve on it by like making Temi more human-like, like greeting the users, having like a more interactive, making it more intuitive for people to approach it. Because with robots, it's a lot like feeling like, oh, maybe I shouldn't touch this, or maybe it's like something that I might get in trouble if I interact with. So that. And then with the automatic facial verification, currently what we've done is have the users manually click the button to take a picture for themselves. Moving forward, we can make the process a lot better by making it automatic. So especially with the second robot, like the second part where you bring yourself there, we can do something like have a grid for the user to place their face there and then perform the what's it called, the facial verification automatically. Lastly, a queue system. So when Temi is busy currently, like when it's moving, like it's bringing someone else to a book, and then someone else tries to communicate with it, we just tell them that the Temi is currently busy, do like pass the request again later. But moving forward, what we can do is maybe implement a queue system. So rather than just saying come back later and then send the request again, we can just queue the action item and then say please wait for a bit, and then automatically once the Temi is free, then say okay, you can go ahead and proceed to the next level. Now we'll be going over our individual contributions. So starting off with mine. Since I was a solution architect, I did a lot of like creating diagrams, writing down the stuff that we need to take note of. So I wanted to like help us shape the project and like the vision of how we want to accomplish it, what our final end product should be. So with all these resources I've created, I helped the team lay out our workflow and action items that are derived from these resources. I also did both front-end and back-end development, so I worked on the Java, the Python code for the Android app and the Python Flask server. I also made the URL, the JavaScript function as well, so it provides like better clarity on how the URL should be utilized in production. Then for the REST DB, I did set it up and the code to set up data collection for future usage. Then lastly, with the project's open house exhibition, I directed and edited the video and the slides, and I'm also the designer of the presentation slides. And next would be Jimmy.
Okay, so for my contribution to the project, I mostly focus on the technical aspects of the project. So basically, any of Temi's functionalities such as Temi's navigation, Temi's face recognition, Temi's picture capturing capabilities, that kind of thing is what I worked on during the project. Next, I developed some essential technologies that we needed for our product to work. So things such as the Flask server for communication, a custom browser for Android linking, and using the Temi SDK to ensure that Temi is able to navigate around the library properly. Next, I was responsible for testing Temi's functionalities to ensure that the app has minimal crashes as well as minimal loopholes for users to exploit. And lastly, I did the troubleshooting and fine-tuning of the code whenever an error, bug, or obstacle would come up. So yeah, next is Chana.
So for me, as I mentioned earlier, I was the team lead and tester. So I was just handling all the administrative tasks that whenever our team has concern, I would reach out to our client, Mr. Jim, or our supervisor, Mr. Ben, to help to sort out our problem. And for a tester, I actually developed the Android app on my phone that simulate the second Temi so that we can test the advanced feature. Then I also created a dummy website that acts like the school one that has a link for us to test the URL on the browser. Lastly, I also designed an open house poster that is easier for the public to understand how our project works. I also see feedback for the public to improve our product's functionalities. Next. So this is the last idea. So we right now we're still like in the development. So for us to deploy, here are the brief steps for us to do. Though because this is a very brief, we will write a very detailed step-by-step guideline in our report for the future developments. Or we can do the deployment for the school. So basically what the school can do is just to deploy our flash server on the, either on cloud on the library server, as long as it's connected to the internet and has the IP address, the internal IP address, and also connect all the terminals to the same network as the server, so that we have 3 IP address. So we'll be able to use these IP address to put inside the configuration files for both the Java application as well as the server, so that they both can communicate with each other using the IP address. So yeah, and then just generate the URL for Mr. Jin to put on the school website, and for them to click using the Android application that, the JavaScript code that Hakimi has written. And yeah, this is an example of the configuration files in our Java. So you can just change the IP address and you can just download the app on Temi. Next. Oh yeah, last slide. It's okay.
Your Grammarly is.
Why you How long was it? 30 minutes. Oh, that's.
You tested the robot and it's bringing to the shelf, right?
Yes.
We're testing a demo later.
Yeah.
Oh, because this is QA for our slides.
Oh.
That's the QA for our demos.
Oh. How was it? You all have any question regarding this? For me, it's more of feedback actually.
Feedback.
Feedback about what?
Yeah, about.
A bit tiny.
The slide. Oh yeah.
All your pictures.
Because this.
Still, you have taken a whole slide.
Oh, you want to see the diagram? We will send the presentation slides.
Just a quick question about the Go server. You all changed from Go to Flash, right?
Yes.
Because it was two-way. Was there further investigation?
Okay, so for the Go server, right, not only was one of the reasons it changed because it couldn't be 2 ways, another reason was that we needed to use the Python library, which was the deface to do facial verification. So when these 2 errors pop up at the same time, it was much more convenient to just switch over to Flask.
So in essence, we faced that problem. Then we also faced we wanted to add the other feature. Then we was thinking, like it might be better to just switch over to Python.
And also deface is a free package in Python they can use. Then in Go we can find like some facial verification for free.
It's fine for us now because if you're going to set up a server, the server is going to, it's just internal.
Yeah, internal, which is need the internal IP address. Can be.
老师我上没有学，老师我上没有学。
Oh yeah. Initially it was Go server.
Okay, so as it works, this technology-wise programming,
Yeah.
which language doesn't matter. It's the end product.
As long as
your
it
user
does
experience.
But
matters.
Go server is still very good. It's very lightweight.
And make sure no vulnerability stuff because you are exposing certain things. No, it's just internally if you are maybe just comment like you are talking about some part you need to use Python because of the facial recognition, right? There's a part you need to use code. There's something called MQ that you can link all them out. Messaging queue.
Messaging.
Or like ETL you just use API.
Oh. Yeah, we actually did research on facial verification API, and most of them actually pay. That's
So
why
we can make our own.
Yeah, but we can also make our own model that use it. But they will took a lot of time. Yeah.
Yeah, the deface was a really fast.
It's a
solution.
it's a free.
People with other issues.
There's concurrency. It's only concurrency issue.
Why do you remove the
But then again,
I'm just curious.
Yeah.
what's your-
Yeah.
Current queue also. I just request 嘛，对吧？
Oh.
It's more straightforward.
You might want to engage. Then the next capstone, you can continue capstone, then CSF help you tighten.
Yeah.
Because of the URL.
Then you can pull up.
And we might
Yeah,
have
actually, the next one will probably, because we will have a mapping system, with the client, right? So not a client, but we are getting a company, so to do a mapping system for us. So basically,